In this question, the graph of the function with rule y equals f of x has a local maximum at the point with coordinates a, comma, f of a, and the graph also has a local minimum at the origin, but no other stationary points. So it's only got two turning points. One's a maximum and one's a minimum. So that makes it a cubic function. And the graph of the function with rule y equals minus 2 f of x on 2 plus k, where k is a positive real number, has one of these happening, either a maximum at the point with these coordinates, and you've got other options as well. So it's saying that it's either got a maximum with certain coordinates or a minimum with certain coordinates, and one of them is correct. So a good way of doing this question is to draw the graph from the information that you're given, and you are given the fact that it has a minimum at the origin and also being a cubic. So you could set it up something like this. So having a minimum at the origin, the graph is going to be doing something like that, and a maximum, I'll just pretend that's a maximum there. So the origin, of course, is 0, 0, and here this is going to be a f of a, and that's the coordinates of the maximum. And what you are being asked to do is look at this graph and then figure out whether it has got either a maximum or minimum with certain coordinates. So looking at what these transformations are, this minus will reflect this graph in the x-axis, so it's going to make it do something like that. And then the 2 is going to dilate it by a factor of 2 in the y direction or from the x-axis, so it's going to make it do something like this. So it's not going to change that point, but this one will go down twice as much as that one was going up. So what that means is that the x-coordinate here will still be a, and the y-coordinate will be minus 2 times what the y-coordinate was, which was f of a. So looking at the other transformations, this x on 2 is a dilation factor of 2 in the x direction, so it's going that way by a factor of 2. So that's going to multiply all the x coordinates by 2. So multiplying this one by 2, it's still going to have the same value. And then when you add k, you're moving the graph up k, so this is going up, but that x coordinate is still staying the same. This whole graph is moving up, so that turning point goes up to a y value of k, but it would have the coordinates 0, comma k. So none of these have a 0 for the x coordinate. So that means that all the maximums in here are incorrect. So that means you can cross out this one and this one and this one. So it's only B or E that are the correct answers. So looking at the actual x coordinate, you need to look at the x coordinate of this point. So this is A, and when you multiply all the x coordinates by 2, because of this dilation factor, that's going to make this 2A. And this is the only one, well, it's the only one of these two that has 2A for the x coordinate. So the answer must be E. And the other thing that happens with the y-coordinate, so this graph, when you dilate it in that direction, that's only going to change the x-coordinate because it's a dilation in the x direction. So that y-coordinate will not change when you apply this transformation, this dilation factor. But what will affect this y-coordinate is this adding k. So the final y-coordinate when you move this graph up k of this turning point will be minus 2 f of a plus k, which is what you've got here. And this one here, you actually had 2 times f of a. So this one was incorrect from the start because it didn't have minus 2 times f of a. So I could have eliminated that a little bit earlier. So anyway, E is the correct answer. And the best way of doing this type of problem is just as I've done, by looking at the transformations one by one and seeing what happens to the turning points in the question. So that's how you do this question, and I'll see you in the next one.